Now, there's a corollary to the circle theorems that we need to be aware of as well. And before I even write down what it is, we first need to have a definition of what a corollary is. So a corollary, this is another one of the definitions that we need to know, is like a theorem, it's a statement in maths that follows quickly and obviously from a theorem without needing to be proved. So it's a statement in maths which follows quickly, and well, mathematicians say obviously. It's not always obvious to lay people. It follows quickly and obviously from a theorem. And the important point here is that it doesn't need to be proved without needing proof. So there's a corollary to the circle theorems. And it states that, excuse me, if two circles touch at a single point, then both their centers are on the same line. So again, that is one that is important for us to learn. You need to learn the statement of that. And let me show you with a diagram what that means. So if two circles touch, a big circle like this, center here, and a smaller circle here, touching it at one single point like this, then the corollary of this statement says that I can join their centers together with a straight line like this. There's another piece of information that goes with this. The radius of the first circle, radius 1, and the radius of the second circle will be the same as the distance between their centers. I should have finished this. They're on the same line with the point of contact. Any 2 points are on some kind of same line. So the distance then between their centers will be the first radius added to the second radius. You should have done that in coordinate geometry of the circle, or maybe you don't remember it. Now there's a second case. They can touch at a single point externally like that, or you could have the smaller circle inside the bigger circle like this. A bit harder to draw. Like that. And then again, their centers will still be on the same line. There's a bit too long. Their centers will still be on the same line with the point of contact. There's the point of contact, like that. But this time the distance between their centers, my small radius and my big radius, R1, is the big radius subtract the small radius. So now the distance between the centers, the distance between the centers will be the big radius take away the small radius. So this is what's called touching externally, and this is called touching internally. One is inside the other. Let's do a quick example of how we might be asked to use those. So if we're told without a diagram, circle A and circle B touch internally. And again, that means one is inside the other. If circle A is the bigger circle, and has a radius of 12 centimeters, and the distance between their centers is 8 centimeters. Okay, it's going to be less than the bigger one because one is inside the other. Find the radius of circle B. So we might draw a sketch to help us visualize this. We've got a big circle like this, and that's circle A. We have a little circle inside it, like so. And what they've told us is that the distance between their centers, the distance there, is 8 centimeters. But we also know that the radius of the big circle is 12 centimeters. So we just subtract one from the other, and that's going to tell us, the leftover bit here, the radius of the small circle. So the radius of circle B is going to be 12 minus 8, which is 4 centimeters. An awful lot of writing for a very quick calculation. So just to be aware of that corollary, you need to know the statement of it, and you need to know what it means and how we use it. Now that's the last new thing that we're learning in this chapter. We do have a bit more geometry to do. We want to do enlargements and constructions as well. But before we move on past this chapter, we're going to do a good bit of practice, because learning the facts and then applying them are two different things. So I'm going to give you a lot of work to do today during your maths class time, and tomorrow it will mostly just be the corrections, the solutions to that work. Okay, thank you.